Now we get to multi-dimensional problems, and these are much more challenging, but they can also be much more fun. Multi-dimensional problems have numbers in the numerator and the denominator. So instead of just having some unit over the number 1, we have a number and a unit over another number and a unit. So you might have to change the units of both the numerator and the denominator, not just the numerator. Now the same rules apply as apply to the one-dimensional problems. The key to multidimensional problems is to do one dimension at a time. So for instance, you might do the top dimension and then do the bottom dimension. Or you might do the bottom dimension first and then do the top. So you want to just look at one dimension at a time. Get rid of the top first and then concentrate on the bottom. So let's look at some of these. Let's look at this. The world record sprinter, which is Usain Bolt, can run 10.4 meters per second. How many miles per hour is this? So we have 10.4 meters per second. We need to know that 10.4 meters per is just 10.4 meters over a second. We don't want to use the little slashes. No. We're going to use 10.4 meters over a second. That's what we start off with. Now we want to end up with miles per, which means divide over hour. Now, so somehow we're going to get from miles, or excuse me, somehow we're going to go from meters per second to miles per hour. So we're going to have to go conversions along the way. Now it seems like, oh my gosh, how do I do that? Well, again, just look at one dimension at a time. Let's look at meters to miles. Well, I don't have a conversion factor directly from meters to miles, but we can do that. We can find a conversion factor, or we can just do kilometers to miles, or we can just, if we can find one, we can go meters to miles, or we can go meters to feet to miles. Now I can use this one, I know this one right off, and I know this one right off. So I think I'm just going to, let's just do the feet, meters to feet to miles. Back up on the top, I'm going to go meters to feet to miles. And in the bottom, I know how to go directly from seconds to hours. That's just 3,600 seconds in 1 hour. So I can do that, or I can just go from seconds to minutes to hours. Either way. Now, you don't have to have the equal number of conversions on the top as the bottom. You can, but you don't have to. You can just do one down here, and you can have 5,000 on top. It doesn't matter. So let's give this a shot. We start with 10.4 meters per second. And again, you can use railroad tracks or the parentheses. And I want to go to feet, then to miles. So I'm going to do that one first. Meters must cancel out, so I have to go from meters to meters. Meters to meters here. And I want to cancel out feet to feet. Feet should cancel out. And I want to be left with miles. So what are the conversion factors there? I know that going from meters to feet, there's 1 meter for every 3.3 feet. And there are 5,280 feet per 1 mile. So I'll just put that in. 3.3 to 1 meter, 5,280. Excuse me, not 5,280 miles per 1 foot. the other way around. 1 mile is 5280. And the fun part, I can cancel out the meters. I'm left with miles. That's great. Now I'm going to do seconds to hours. So that means the seconds must be on top. Let's try seconds must be on top. And the hours must be on the bottom because I want it miles per hour. So that means the miles must be on top and the hours must be on the bottom. And I'm going to cancel those out. How many seconds are in an hour? We have 3,600 seconds in an hour. Or miles per hour. And these are not significant digits. They're just true values or conversion factors. We look at this for the sig figs. There's 3 sig figs there, and it comes out perfect because there are 3 sig figs there. And that's incredibly fast. And that was 23.4 miles per hour over the 100 meters that Usain Bolt ran. Now, it makes sense. If it was something like 5,000 miles per hour, then you know something's wrong. Or if it was 2 miles per hour, you know that it's not very fast, so that would be incorrect. So when you're doing these problems, make sure it makes sense.